Hey pre-calc students, today we're going to talk about the sum and difference identities in terms of degrees. So just for the record, all these identities that you see over here in this box on the left are not required of you to memorize. So you will always be given these and you will be allowed to use a calculator, but you need to show all your work. So make sure that you know that you need to show your work, okay? Even though you are allowed to use a calculator, okay? All right, so here is the unit circle with most of the reference angles for 30, 60, and 45 labeled. Notice that I did not label 0, 90, 180, or 270, so I'm not including quadrantal angles here. I'm just looking at all the reference angles. So if you look at 30 and 150, also 330 and 210, all of those have a reference angle of 30 degrees to the x-axis. 135, 225, 315, and 45 obviously all have reference angles of 45 degrees to the x-axis. And then you can see the 120, 60, 300, and 240 all have a reference angle of 60 to the x-axis. Okay? So the goal is, guys, for this lesson, for you to be able to find values of the sine of an angle, cosine of an angle, or tangent of an angle that is not a special angle, reference angle, like 30, 60, or 45. But you're going to use your knowledge of those to hopefully figure out the problem, okay? All right, really quickly, one of the things, a common mistake I see very often is people, when they see the notation of, let's say, sine of two angles, alpha and beta. They think that they can distribute sine, but that's not how that works or what that means. So you can see this example, right? If I let alpha be 180 degrees and beta be 90, what they really, this notation of sine of alpha plus beta means you're supposed to add the angles together, okay, versus distribute the sine. So they are not equal in terms of their answer. So sine of beta and alpha, which would be 270, that answer is -1, is not the same as if you distribute sine and do sine of alpha plus sine of beta, because that would give you +1. Okay, so really important, make sure that you understand that you can't just distribute sine. um, or cosine or tangent for any of these sum or difference. They have their own patterns. Okay, so again, you don't have to memorize the patterns, but you have to know how to use them. Okay, so let's just start off with some angles that we're familiar with. As always, since we're dealing with special triangles, it would be a good idea for you to write down your, oops, I almost started writing in radians. Your special triangles, 30, 60, 90, label your sides. And then your 45, 45, 90. Oops, that came out a little crooked. Okay. All right, so sine of 45 degrees plus 120 degrees. So that's really the sine of 165. Um, but we don't know what the sine of 165 is because 165 doesn't have a reference angle of 30, 60, or 45. So split up, you can figure it out. So you can find the answer. So the pattern for sine of alpha plus beta is take the sine of the first angle times the cosine of the second angle. So I'm using the pattern the from the sine of alpha plus beta, right? For the sum. Okay, so I'm following that pattern. Plus cosine of the first angle, which we call alpha, and sine of the second angle, which we call beta. Okay, so using your knowledge of angles, of special angles, and reference angles, sine of 45 degrees is opposite over hypotenuse, which is 1 over root 2. But if you rationalize that, that would be root 2 over 2. And remember that 45 degrees is in quadrant 1. So sine is positive in quadrant 1. Okay, so again, I'm going to write it off on the side here. Sine of 45 is opposite over hypotenuse, but if you rationalize it, you get root 2 over 2. Okay, now cosine of 120, that's in quadrant 2. And again, you feel free to look up here at this, right? 120 is in quadrant 2, and cosine is negative in quadrant 2. The reference angle of 120 is 60 degrees. So we're going to use the 60-degree angle in our triangles. So cosine of 60, which is our reference angle for 120, is adjacent over hypotenuse. So 1/2. But again, because it's in quadrant 2, it's going to be negative. Plus the cosine of 45, so back to quadrant 1, cosine is adjacent over hypotenuse. That's going to be 1 over root 2, which rationalized is root 2 over 2. And then sine of 120, so back to quadrant 2, 120 degrees has a reference angle of 60. Sine is positive in quadrant 2. So from 60 degrees, opposite over hypotenuse is root 3 over 2. Okay. All right, and then we simplify. So you're going to multiply the numerators and the denominators for both parts. Okay. Notice that the denominators are going to be the same here. So you're going to have negative root 2 over 4 plus root 6. When roots are not the same, well, they could be the same or not, but when they're not the same, you just multiply whatever number's inside and then you combine them. And then because these have the same denominator, you can write the answer as negative root 2 plus root 6 all over 4. Remember, you're more than welcome to pause the video, rewind, whatever you need to do to make sure you're understanding this. Okay, so now for cosine of 45 minus 210, feel free to write yourself the reference angles. I probably should have done that over here. So the reference angle for this one is 30 degrees. 210 is 30 degrees away from 180. You can even look at the graph over here, right? 210 is 30 degrees away from 180, okay? Okay. All right, so cosine of 45 minus 210 follows the pattern of cosine of the first angle times cosine of the second angle. How did I get that? Remember, I'm using the properties that apply. So because it's a cosine and it's in a subtraction, I'm following this pattern right here. Cosine of alpha, cosine of beta, plus sine of alpha, sine of beta. Sine of the first angle and sine of the second. Okay. 45 degrees is in quadrant 1. Cosine of 45 is 1 over root 2, but rationalized, it's root 2 over 2. 210 is in quadrant 3. Cosine is negative in quadrant 3. The reference angle for 210 is 30, and the cosine of 30 is root 3 over 2, but remember it's going to be negative because cosine is negative in quadrant 3. Okay, sine of 45 is root 2 over 2. We did that in the previous problem. So if you remember, it's 1 over root 2, but then you rationalize it. Sine is negative in quadrant 3. So the reference angle is 30 degrees. Sine of 30 is 1/2. Then you do the same exact thing that we did last time. Multiply the numerators and the denominators. And then if they have the same denominator, you're welcome to combine them and put them all over 4. So as you can see, everything that we've done before in chapter 4 and chapter 5 with special angles like 30, 60, and 45 is absolutely critical for this lesson. Okay, so for the next couple problems that are coming up, we're going to practice doing the separation that was already given to us in number 1 and number 2. You see how they had 45 degrees separated from 120 as a sum or 45 minus 210 separated with a difference. We're going to practice creating those sums and differences to obtain the result in the given angle. For example, they've given us negative 15. So what you're going to try to do is you're going to try to use either 30, 45, 60, or pretty much any angle in the unit circle, because all these have a reference angle of 30, 60, and 45. Okay. You're going to use any of those angles to help you get an answer of negative 15. But my suggestion is use the smaller angles if possible. Okay. So how can I use 30, 60, or 45 to get negative 15? If the answer is I can't really use any of them, then you can start looking at angles in quadrant 2 or quadrant 3 or quadrant 4. Okay, so think about it for a second, pause the video. What angles can I use to create negative 15? And remember, they have to be related or they have to be exactly 30, 45, or 60. So related to 30, 45, 60 or exactly 35, 45, 60. Okay, pause the video, make sure you give it a try. Push play when you're ready. Okay, so I chose the combination of 45 degrees minus 60 degrees. That gives you negative 15. And notice that on here I made a note that this can take some time before you can find the correct combination, and sometimes there's more than one right answer. Okay, try the same thing for 75. How can I use 30, 60, or 45 degrees to create 75? And remember, you can create a sum or difference. So in number 3, that was a difference. Remember, difference means subtraction. For this one, I used 45 and 30. So that would be a sum, okay? So you can use a sum or a difference to create the angle given. Because if I were to ask you to find the sine of 75, 75 is not a special angle, right? A special reference angle. But if you can break it down using your special angles that you know how to work with, anything related to 30, 60, or 45, then you can figure out the answer, okay? So again, let's say I were to ask you tangent of 105. 105 doesn't have a reference angle of 30, 60, or 45. But what I can do is I can find combinations of angles that can create an answer of 105 and use that to actually evaluate a trig function for 105. So pause the video and try to come up with a couple combinations, if possible, of how to use 30, 60, 45, or any of the angles related to them. Remember, they're all up here to get an answer of 105. So pause the video and then push play when you're ready. Okay, so here I'm giving you an example of a sum or a difference. And although while you're doing your work in the next couple problems, your answer might look, let's say that you picked a sum to represent 105 and a friend of yours picked a difference, your final answers might not look the same, but they should have the same exact decimal value. So I'll explain that in a little bit. All right, so again, the goal is, guys, from now on, I'm going to give you a trig expression to evaluate or simplify. Okay, so for example, I'm asking you to find the tangent of 105. So this is what I'm asking you to find. Well, 105 doesn't have a reference angle of 30, 60, or 45. So what you want to do is you want to find either a sum. So option 1 is to find a sum, a way to find two angles related to 30, 60, 45, or including 30, 60, 45, to rewrite the angle you're interested in, okay, which is 105. Or you can find a difference. So pause the video and try to find either a sum or a difference. right? Two angles that add or subtract to get 105. But remember, they have to be from that circle on the front page. Pause the video, push play when you're ready. Okay, so I chose 60 and 45 for the sum. Okay, so to evaluate it, I'm going to follow the pattern that goes with tangent of a sum of two angles. Now, just so you know, on Google Classroom, I put an example of how to solve this with a difference. So when you get a chance, feel free to look at it. But for this video, I'm going to explain how to do it with a sum. Okay, so the pattern is you take the tangent of the first angle, add the tangent of the second angle, divide it by 1 minus tangent of the first angle and tangent of the second angle. So first and foremost, let's make sure that you pause the video right now and find the tangent of 60. Find the tangent of 45 so then you can plug them in. Notice that both of these angles are in quadrant 1, so you don't have to worry about whether it's negative or not because it's in quadrant 1. Everything's positive in quadrant 1. Okay, so pause the video, find those. Push play when you're ready. Okay, so I'm just filling in my answers. Tangent of 60 is root 3. Tangent of 45 is 1. Okay, and then over here, tangent of 60 is root 3. Tangent of 5 is 1. Um, Root 3 times 1 is just root 3, but I want to make sure that you guys know that oftentimes the way that answers are written is you put the rational number first, so the one that's not a root, or sorry, an imperfect root in front, and then you put the imperfect root. We call those irrational. So then this one would have the the way you'll see it on multiple choice tests is like this, okay? Or even in my answer keys, you'll see the rational number first, then the irrational number. Okay, so previously to this, if I had asked you to find the cosine of 165, you wouldn't have been able to because the reference angle for 165 is not 30, it's not 60, and it's not 45. However, you can use 30, 60, 45 or angles from the unit circle to help you rewrite 165 as a sum or a difference. Okay, so you could write it as a sum or a difference. Just for the sake of this video, I'm going to use a sum. Okay, so try to find two angles from the unit circle with reference angles of 30, 60, or 45 to rewrite and split up 165 as a sum. Okay, so remember, we're trying to rewrite 165 as a sum so that we can find the cosine of that angle. Feel free to pause the video right now, try to find those numbers yourself. I always try to stick to numbers that are in quadrant 1, but no matter how I add 30, 60, and 45, when I add two of them together, it'll never get me um, to 165, right? Because 30 plus 60 is 90, 60 plus 45 is 105, so etc. So you won't ever get to 165 from just adding 30, 60, 45. That means you're going to have to start looking at bigger angles, and maybe in quadrant 2 or 3. So I chose to use 120 and 45, right? 120 has a reference angle of 60 degrees, and 45 has and 45 is in quadrant 1, it's a reference angle itself, right? A special reference angle. Okay, so now I'm going to follow the pattern. So cosine of my first angle times cosine of my second angle minus sine of my first angle and sine of my second. So take a minute, and this is the most important part, guys, is make sure that you're plugging in the right values. So take a minute and ask yourself, what quadrant, right, are these angles in? So this has a reference angle of 60 degrees. It's in quadrant 2. Cosine is negative in quadrant 2. If you do adjacent over hypotenuse for 60 degrees, you get 1/2, but again, it's going to be negative because it's in quadrant 2. Cosine of 45, that's in quadrant 1, so that's positive, is adjacent over hypotenuse, but if you rationalize it, you get root 2 over 2. 120 is in quadrant 2, but sine is positive in quadrant 2. Reference angle is 60, so the sine of 60 is root 3 over 2. And then the sine of 45, that's in quadrant 1. It's positive. It's 1 over root 2, but rationalize, it's root 2 over 2. So now, my dog is snoring in the background. I don't know if you can hear him. You get negative root 2 over 4 minus root 6 over 4, which you can put in 1 as one fraction with a denominator of 4. Now, just so you guys know, the two values on the top on the numerator are being subtracted. Order matters in subtraction, okay? So make sure that you are writing it as negative 2 minus root 6, okay? Now, you could have used a difference. So you could have also subtracted 210, same numbers, different order. 210 minus 45 degrees. Okay, and I put the answer for that on Google Classroom, so feel free to check it out. All right, guys, so the main objective is for you to be able to evaluate and simplify trig expressions that you didn't know how to do before, because the reference angle, for example, right here is 165. That doesn't have a reference angle of 30, 45, or 60, but you can split it up using your special reference angles. Like in this case, I used 125 and 45. You could have used 210 and 45. Okay. All right. As always, if you need any extra help or have questions, feel free to reach out. Your homework is the bottom part, and I attach the answer so you can check. As always, if you find a mistake or see something wrong, let me know because I'll give you extra credit if you help me find mistakes. Have a good day. See you soon.